G'day, in my last video I showed you how to use a water model like this to really drive an intuitive grasp in students of voltage, current and resistance. But in this video I want to take it up a level and talk about those working scientifically skills, particularly around scientific modeling. Now when students think of models, they probably think about the model cell that they made out of Play-Doh and the labels that they put on it, and that's great, that is a structural model. But functional models is kind of where things are. And if we want to teach science the way that it's actually practiced, most of science is around developing and exploring and testing models and making them more like reality. That process of making observations, our model makes a prediction. We think, okay, how do we go and design an experiment to test that prediction? And then what might that mean to changing our model? So this is a great way to give students experience of that process. Now the best thing is for students to make the observations themselves. So let me just show you a few possible ways that you could use this and give them some examples. So first of all, I've set this up with a switch that is open, and this is modeling a light globe, a component with some resistance. And I can make some predictions from my model about the voltage drop is all across the switch and kind of nothing across the light globe, and I can turn the switch on and let the current flow, and I can now make some different observations around where the voltage drop is, virtually nothing across the switch. And if we look really carefully, there is an ever so tiny voltage drop across the first wire. Now that might be challenging for you to measure when the power supplies that we use in a science lab are only 5 amps and the wires are pretty thick, but with a good voltmeter you might be able to measure that. Nevertheless, it's a prediction made by this model. Another thing that students often struggle with is, what if we reverse the order of the components in the circuit? And they often think that's going to make a difference. So let's model that. Let's reverse the order of the components in the circuit. Again, we can make some predictions with the switch open and then make some predictions from the model with the switch closed. And namely, the predictions are it doesn't actually change things which order those are in. Now I can think of probably about 10 or more different observations that would be able to be turned into a testable hypothesis, and then with real light globes and switches you could gather the data to evaluate that hypothesis and therefore evaluate the model. But that would take away the fun from our students, because really the cycle that we want to give them is the ability to make good observations, from that inferences, and then develop testable hypotheses, and then think about how do we manipulate the apparatus to gather the evidence to evaluate the claim. So in my next video I'm going to go away from this model, but continue in the series of making electricity visible and show you a wonderful mystery circuit simulator, which also takes students through a process of developing hypotheses and then testing them to see whether they're right.